Welcome to Cutaway, Australia's skydiving malfunctions training video. I'm Dr. Glenn Singleman, and I'll be your host today as we talk about malfunctions and emergency procedures. This video is designed for students preparing to take their very first skydive, together with demonstrations from Australian champion skydiver Michael Vaughan. We'll discuss the different types of malfunctions that can occur and how to respond effectively using emergency procedures. We'll also cover minor problems that can occur on opening and how to respond to these. But before we get to malfunctions, let's recap on a stable deployment resulting in a good canopy and how to identify a good canopy that you can land safely, because it's most likely that that's what will happen on your first skydive. As you now know, it's important to remember the key words and associated actions your instructor has taught you. Let's run through the key words used during deployment and good canopy identification.
To achieve a stable deployment, we need to use the key words locate, grip, throw, arch, 1,000, 2,000, 3,000, check, 5,000, 6,000. Once the canopy is deployed, we go into our routine canopy inspection using the following key words: size, shape, straight, slider, twist free, toggles, 2 flares. Size. Check that the canopy is large, undistorted, no rips, tears or broken lines. Shape. That the canopy is rectangular, unrestricted and the end cells are fully open. Straight. By picking a point on the ground, we check that the canopy is flying straight and not turning in any way. Slider. The slider must come all the way down to the top of the risers at the bottom of the lines. Twist free. That the lines are not twisted. Toggles. When you've confirmed the previous steps, you should release the toggles located at the rear of the rear risers. 2 flares. By pulling the toggles down to your hips in a fluid smooth action, complete 2 full flares. Even with a good arch and a perfectly stable deployment, it is possible for the pilot chute to become trapped in the jumper's burble, causing a delayed deployment of the main parachute. This is called a pilot chute hesitation. This can easily be remedied by turning a shoulder and exposing the pilot chute to the airflow, allowing it to catch air and deploy the main parachute normally. This is generally achieved when you check over your shoulder during your count. As discussed, a stable deployment position aids a clean and proper opening of the main parachute. An unstable deployment can cause deployment complications resulting in main canopy malfunctions requiring emergency procedures. Nevertheless, the highest priority is always to pull at the correct altitude regardless of stability.
In the extremely unlikely event of a malfunction, you'll need to know how to identify a high-speed versus a low-speed malfunction. But before we cover these scenarios, let's take a look at some routine opening problems you may be faced with and how to deal with these effectively.
The cause of line twists are generally a poor body position on opening, a spinning deployment bag, or being in a spin during deployment. The effect of line twists is that you cannot steer the parachute. Line twists must be cleared before releasing the brakes. The remedy for line twists is, after completion of our canopy inspection, where we assess the size, the shape and also our altitude, is to pull the risers apart and kick our legs in a bicycle-type motion, ensuring that we do not release the brakes until the line twists are cleared. We then continue with our canopy procedures and locate the drop zone. If your assessment doesn't meet the size, shape or altitude criteria, then this is a malfunction. With end cell closures, low pressure in the end cells can cause the nose over those cells to remain closed. The effect of end cell closures is, even though the canopy is open, it will have restricted steerability and overall performance. The remedy is to complete the last part of your canopy inspection by grasping the toggles and smoothly performing 2 full flares. By completing 2 full flares, this equalises the pressure throughout the canopy. The brakes are set during packing to reduce the forward surge of the canopy on opening. The cause of a premature brake release is where the slider dislodges the toggle on opening or a hand reaching for toggles during the opening sequence. The effect is your canopy will be turning. The remedy is to grasp both toggles and smoothly perform 2 full flares. This will stop the turn. We then continue to locate the drop zone. The slider is designed to restrict the opening to an acceptable speed. The cause of a slider hang-up is where the slider is doing its job too well. It may not come all the way down to the top of the risers. The effect of the slider remaining up will diminish the size and performance of the canopy. The remedy for a slider hang-up is to grasp the toggles and smoothly perform 2 full flares, bringing the slider down to the top of the risers.
And in a lot of cases for the routine opening problems, it's the magic 2 flares. And if we can resolve it, we end up with a perfectly good parachute, then it's like, thank God, I can land this one. I don't need to start going through my emergency procedures.
Malfunctions are uncommon. However, with all mechanical devices like parachutes, they can and do occur. Firstly, you need to be able to recognise what a malfunction looks like. Secondly, after recognising the malfunction, you need to make a decision on the remedy and take the appropriate action immediately. This may mean committing to emergency procedures.
At any stage in your skydiving, whether being a student or an experienced jumper, you need to make a decision. You need to firstly identify a good canopy. Now, if you're not happy with the canopy, you need to make a decision, okay? And you need to make a decision before 2,000 feet.
Going through your emergency procedures isn't that hard at all. It's just a matter of, pulling two handles, pulling them in the right sequence, and voila, we have a perfectly good functional reserve over our heads.
In an emergency situation, you may experience sensory overload, which can include tunnel vision and a distorted perception of time, a loss of height awareness, a loss of manual dexterity, or a freeze response, like a deer in the headlights. The best way to prepare yourself is to overlearn your decision-making process and your emergency procedures. Drill, visualise, repeat.
If we're very good at practicing those procedures, then it all should be pretty automatic.
Let's recap the emergency procedures your instructor has shown you. For the DOS system, the key words are legs, look, locate, peel, punch, pull, arch. You may need to use these emergency procedures in the event of a low-speed or high-speed malfunction, so you need to learn them thoroughly.
Legs. In a majority of cases, we will probably experience a low-speed malfunction. This means that we will have something above us, and this puts us into a feet-to-earth attitude. By forcing our legs back and pushing our hips forward, when the cutaway handle is pulled, we will naturally fall back into a belly-to-earth attitude. The belly-to-earth attitude will give the reserve the best platform from which to deploy. Failure to have a belly-to-earth attitude could result in a scenario where you may become entangled in your deploying reserve. Look at the red cutaway pillow. If you don't look at the pillow, when it comes time to physically grasp it, you may fumble for it. This equates to seconds, and seconds equate to hundreds of feet in altitude. It is better to take the time to look at the handle rather than chew up valuable time trying to find it. Locate. Grasp the red cutaway pillow with the thumb over the top. This will give you a good grip for the peeling action which happens next. Look at the silver ripcord handle. We look for the handle first for the same reasons we looked at our red cutaway pillow. Locate. Grasp the silver ripcord handle by ensuring that the thumb goes through the handle and the fingers lock over the top of the thumb. This method ensures a solid grip on the handle. Peel. Once both the red cutaway pillow and silver ripcord handle are firmly gripped, we then peel the cutaway pillow up in a rotating motion, separating the male and female Velcro. This action will significantly reduce the amount of strength required to pull the cutaway pillow from its pocket. Punch. Once the cutaway pillow has been peeled from its pocket, the right hand is punched in a downward motion to full arm's extent. Pull. Once the cutaway pillow is punched to full arm extent, the left hand then pulls the silver ripcord handle in a downward motion to full arm's extent. Arch. Once both arms are at full extent, we transition back to a hard arch body position.
Now that we've reviewed emergency procedures, it's important to be able to recognise the difference between routine opening problems and real malfunctions. There are two categories of malfunctions: low speed and high speed. Low speed malfunctions occur when the canopy has 5 or more cells open. your vertical descent rate will be dramatically reduced, and you may have some limited time to assess the situation, decide, and act. This compares to high-speed malfunctions where you may be travelling at terminal velocity with very little time to act. Let's look at the causes, effects, and remedies for low-speed malfunctions.
Any unusual deployment may cause uneven tension on the suspension lines, resulting in tension knots or a stabiliser hanger. Once again, the need for stability on deployment is critical. Tension knots will affect the symmetry of the canopy, resulting in it having a higher rate of descent and the canopy rotating rapidly, causing centrifugal force. The remedy for tension knots is to grasp the toggles and smoothly perform 2 full flares. This will stop the turn and slow the canopy down. Maintain height awareness and be prepared to initiate emergency procedures by 2,000 feet. Maintaining height awareness is critical in all malfunction scenarios. You must make a decision by 2,000 feet and commit to either cutting away or landing it. Out-of-sequence deployments can cause line-over malfunctions. Once again, the need for stability on deployment is critical. In effect, you would expect a low rate of descent, possible canopy rotations, and lack of controllability. The remedy for a line-over malfunction is to grasp the toggles and smoothly perform 2 full flares. This may allow the line to clear the canopy. Maintain height awareness and be prepared to initiate emergency procedures by 2,000 feet.
I think it can really help us with our confidence to actually go through a malfunction at some stage and have to go through our emergency procedures. It gives us lots of confidence in our equipment, gives us lots of confidence in our abilities and faith in our training and faith in ourselves.
Unusual forces on deploying canopies can be caused by a head-down or unstable deployment. Age and sun damage can also contribute to the strength of the canopy. The effect of the tears or holes in the canopy may create an unusual shape which may be uncontrollable. The remedy for a damaged canopy is to initiate emergency procedures by 2,000 feet. Broken lines can be caused by an unstable deployment which exerts unusual forces on the lines. Line strength also deteriorates with age and exposure to sunlight. The effect on the canopy may be an unusual shape, it may be uncontrollable, and broken lines may be hanging below you. The remedy is to conduct the controllability check. Locate your toggles, do 2 full flares, a left turn, a right turn, and if it's still uncontrollable, initiate your emergency procedures by 2,000 feet. A pilot chute over the nose can be caused by a fast, sharp opening. The effect is that the canopy may stall when flaring and may have limited steering. The remedy for a pilot chute over the nose is to carry out your controllability checks. Grasp your toggles, conduct 2 full flares and left and right turns. If the canopy exhibits poor handling, be prepared to carry out your emergency procedures before 2,000 feet. A jam brake can be caused by the excess brake line becoming dislodged and entangled during deployment. The effect is limited steering ability, since one brake is locked in position while the other can move freely into either full drive or the full flare position. The remedy is to make 2 attempts to free it. If unsuccessful, initiate emergency procedures by 2,000 feet.
If you have less than 5 cells open, you have a high-speed malfunction. High-speed malfunctions require rapid assessment, decision and action. In these situations, you're losing altitude fast. Let's take a look at the different types of high-speed malfunctions.
The cause of a hard pull is where you cannot deploy your pilot chute on the first attempt. It may be that you require more effort. The effect is that you remain at terminal velocity. The remedy is to confirm your grip on the pilot chute, dig your elbow into the side of the container and attempt to lever. If you still can't get it out, commence your emergency procedures immediately. Do not sacrifice altitude. A pilot chute in tow is when the pilot chute has been deployed but failed to open the main container. The effect of having the pilot chute towing behind means that you are still at terminal velocity. The remedy is to complete the time awareness count and go immediately to your emergency procedures.
For a long time, my biggest fear was a pilot chute in tow, because for some reason, whether it's an uncocked pilot chute or it's a closing loop that's too tight or a misrouted bridle, I've got a pilot chute towing out there behind me, and there's not really a lot I can do except cut away and then deploy a reserve out past it. And if the main then comes out, then I can end up with a main reserve entanglement.
The cause of a total malfunction is where the main deployment handle cannot be located or deployed. The effect is like previous scenarios where you're still at terminal velocity. The remedy is to make only 2 attempts to locate your handle. If you're still unable to locate and deploy, immediately commence your emergency procedures. The cause of a bag lock may be that the lines have wrapped around the bag during deployment, or that the mouth of the bag is locked off. The effect is that you're still at terminal velocity and could also be in a feet to earth attitude, which increases your speed. The remedy for a bag lock is to complete the time awareness count, then go immediately to your emergency procedures. A streamer is where the canopy is out or partially out of the deployment bag but is failing to open. This can be caused by physical damage, uneven line deployment and entanglement, or even a slider hang-up. The effect is a feet-to-earth attitude and a high rate of descent. Also, the slider may not be visible or rectangular in shape. The remedy is to complete the time awareness count and immediately commence your emergency procedures. As with a bag lock or pilot chute in tow, your count will allow you to maintain time awareness in a high-speed malfunction situation. If you reach the end of your count and you're still travelling at terminal velocity without a normal deployment, you should initiate emergency procedures. A horseshoe malfunction can be caused by an unstable deployment or a dislodged pin that opens the main container while the pilot chute remains in the BOC pouch. One possible effect is the bridle becoming entangled with the jumper. Another possible effect is the bag being out of the container with the pilot chute still in the BOC pouch. In both situations, you will be at terminal velocity. The remedy for both situations is to initiate your emergency procedures immediately.
The other big high-speed malfunction that I've always been worried about is a horseshoe, which again, I've got my main connected to me in 2 places, and cutting away may not disconnect that from me in both those places, and deploying a reserve then also means that the reserve has to get out past that main and hopefully not get entangled and end up with a main reserve and entanglement.
As you have seen, there are a number of high-speed malfunction scenarios, all of which require the initiation of emergency procedures. Remember, you don't have time to analyse or fix the problem. You need to act immediately. You may be faced with a situation where you have two canopies deployed. Both the main and the reserve parachutes are out of the container. It's been shown that the two canopy configuration can be landed safely, but you may need to use emergency procedures in this situation. Let's have a look at 4 possible configurations.
There are several configurations where you can have two canopies out. They are usually classified as low-speed malfunctions since both canopies are fully inflated. They all share two common causes, either a low pull while the AAD is firing, or a dislodged reserve pin, which can allow the reserve parachute to deploy as you deploy the main. A side-by-side is where two canopies are flying wingtip to wingtip in the same direction. The effect is that you'll have a relatively slow rate of descent. The remedy is to fly the dominant canopy gently and leave the other canopy's brakes stowed. Land without flaring and do a PLR. If the canopies show any indication of separation whatsoever, then the main canopy must be cut away. A biplane is where the canopies are flying one in front of the other. Again, the effect is that you'll have a relatively slow rate of descent. If the leading edge of the rear canopy is underneath the trailing edge of the dominant front canopy, it's usually pretty stable and can be landed safely. The remedy is to fly the dominant canopy gently and leave the other canopy's brakes stowed, land without flaring and do a PLR. If the leading edge of the dominant rear canopy is above the trailing edge of the front canopy, it may develop into a side-by-side or even a downplane. The downplane is where the two canopies are flying apart in opposite directions, with both canopies diving towards the ground. The effect is that you'll have a relatively high rate of descent, so it can be considered a high-speed malfunction. The remedy is to jettison your main parachute immediately by pulling your cutaway handle. Two out with a deflated second canopy occurs when one canopy has inflated fully, while the other is either still in the bag or in a partial state of inflation. The effect is that the second canopy is trailing behind. If it's out of the bag, the canopy could inflate and cause entanglement. Your rate of descent will be relatively slow since you have a fully inflated canopy above you. If either canopy remains in the bag, the remedy is to gather it up and smother it between the legs to prevent inflation. If the main canopy deploys fully, with the reserve in a partial stage of deployment, the remedy is to shake the risers to aid deployment and prepare to take action with the resulting configuration. If the reserve deploys fully and the main canopy is in a partial stage of deployment, the remedy is to pull the cutaway handle immediately.
In this video, we've shown you how to identify a good canopy you can land safely and how to deal with routine opening problems. We've also shown you correct emergency procedures and how to identify low-speed malfunctions and high-speed malfunctions. Chances are you won't have to face any of the malfunctions we've shown here today, but you now know how to judge when to use your emergency procedures. The decision will be yours. Skydiving is one of the most amazing experiences you'll ever have. Your instructor has now taught you everything you need to know to pass your written exam and make your first skydive successfully. Good luck with your exam. If you have any doubts about your ability to deal with any of the scenarios we've covered today, talk to your instructor. Remember, every skydiver has stood trembling in your shoes and made their first jump. And we all remember the incredible amount of courage it took. Good luck.
And welcome to skydiving! Yeah!
That was rad. Excellent.